Hi everyone, myself K.Nouseen Taj. I am from CSM-B section from SRIT College. Today we are discussing about construction and working of zinc air and lead acid batteries. Firstly, we will note what is a battery. A battery is a device that converts chemical energy into electrical energy. It consists of two or more electrochemical cells connected together. Batteries are classified into two types. They are primary batteries and secondary batteries. Here, primary batteries are non-rechargeable batteries and secondary are rechargeable batteries. And now they play a major role in portable devices like vehicles and energy storage systems. Next, classification of batteries, primary batteries and secondary batteries. Primary batteries used once and cannot be recharged. Like example, zinc air battery, dry cell. And secondary batteries can be recharged and be used multiple times. Example, lead acid battery, lithium ion battery. Now what is zinc air battery? The zinc air battery is a primary battery that uses oxygen from the air as a reactant. It has a high energy density and is lightweight, commonly used in hearing aids and remote sensors and also electrical vehicles. Here reaction takes place between zinc and oxygen. Here zinc is act as anode and oxygen as cathode. Now construction of zinc air battery. Anode is zinc metal that is oxidized during discharge, and cathode porous carbon electrode exposed to air and coated with a catalyst. Electrolyte is aqueous potassium hydroxide that is KOH. The battery casing allows air entry through small holes for oxygen supply. Here anode is a porous mass of zinc particles. Cathode is an air electrode with a catalytic layer to facilitate the oxygen reduction reaction and a gas diffusion layer. Electrolyte is an alkaline solution like KOH. Here we are also using separator, that is a porous separator keeps the anode and cathode from touching while allowing ions to pass through. And now next we'll see working of zinc air battery. Here at anode, zinc gives rise to Zn2 plus 2 electrons, and at cathode O2 plus 2H2O plus 4 electrons gives rise to 4OH minus, and overall reaction is 2Zn plus O2, that is 2ZnO. Electrons flow from zinc anode to the air cathode, generating electricity. Now here working discharge. Zinc at anode reacts with hydroxyl ions to form zincate, releasing electrons. Oxygen from the air is reduced at cathode, combining with water to form hydroxyl ions. The overall reaction produces current. Now we will see applications of zinc air battery. We can use zinc air batteries in hearing aids and medical devices, electric vehicles, backup power for telecom and signals, remote monitoring equipment. And advantages and disadvantages of zinc air battery. Advantages means it is very high energy density, it is very low cost and lightweight, environmentally friendly. If we come for disadvantages, these are not rechargeable and performance affected by humidity and carbon dioxide and limited power output. And now next we will see lead acid battery. Here lead acid battery is a secondary battery, that is it is rechargeable. It was invented by Gaston Plante in 1859, commonly used in automobiles, UPS systems and inverters. Operates based on reactions of lead and lead dioxide in sulfuric acid. Now if we come for construction of lead acid battery, first we will see what are components of lead acid battery. First is anode, that is sponge lead Pb. Cathode is lead dioxide. Electrolyte means dilute sulfuric acid. Separators prevent short circuit between plates. Casing is hard rubber or plastic container. Here positive electrode we are using is PbO2, negative is Pb, electrolyte as it is dilute sulfuric acid. Here separators, a porous separator is used between the electrodes to prevent short circuit. Now, working of lead acid battery. Here during discharge, both lead oxide and sponge lead electrodes react with the sulfuric acid electrolyte to form lead sulfate. This process generates a current through external circuit. During recharge, an external voltage is applied reversing the reaction and converting the lead sulfate back into lead. Lead dioxide and sulfuric acid stored as chemical energy. Here at anode, Pb plus SO4 2 minus gives rise to PbSO4 plus 2 electrons. At cathode, PbO2 plus 4H plus SO4 2 minus plus 2 electrons gives rise to PbSO4 plus 2H2O. Overall reaction is Pb plus PbO2 plus 2H2SO4 gives rise to 2PbSO4 plus 2H2O. And now next, what is meant by charging and discharging cycle? Discharging means converting from chemical energy to electrical energy. Charging means electrical energy is converted into chemical energy. The alternator in vehicles charges the battery. Repeated charge means discharge cycles cause gradual loss of capacity. Now we will see advantages and disadvantages of lead acid battery. Advantages of lead acid battery, they are very low cost and reliable, high current output and easy to recharge. For disadvantages, it is very heavy and bulky, limited life cycle and environmental hazard due to lead acid. Now, we will see the differences between zinc air battery and lead acid battery. Here, zinc air battery is a primary and lead acid is a secondary battery. We cannot recharge zinc air battery, but we can recharge lead acid battery. In zinc air battery, anode is zinc, cathode is air, electrolyte is KOH. In lead acid battery, anode is lead, cathode is lead dioxide, electrolyte is H2SO4. Zinc air battery applications are sensors, lead acid battery are cars. Now, the environment impact from zinc air battery is very low, but lead acid battery is moderate to high. Energy density is very high in zinc air batteries and moderate in lead acid batteries. Now we'll come for conclusion. Zinc air batteries are efficient, lightweight, primary cells. Lead acid batteries are reliable, secondary cells widely used in vehicles. Both play key roles in energy storage. Future research aims to develop rechargeable zinc air batteries. Thank you.